Yo, what's up? Ricky Sanders here. If you live for fast cars, greasy hands, and solving problems under the hood, welcome to your new favourite spot. I'm all about real fixes, no BS, and showing you how to keep your ride running like a champ. So go ahead, smash that like button, hit subscribe, and let's make some noise in the garage. Enough talk. Let's get ready.
In history, the 1AZ series in the early 2000s replaced the previous line of 3S engines that had been produced for Toyota Motor Corporation since 1982. Among them was the first gasoline engine with direct injection, DI, or GDI, gasoline direct injection, in international terminology. Motorists nicknamed such engines Jedi. We are talking about the 3S-FSE unit. 1. Serial number. A. Engine series. Z. Gasoline. F. Standard power range. S. Direct fuel injection. E. Electronic multipoint injection. The 1AZ engine was also produced in a simpler version, 1AZ-FE, that is, instead of direct injection the distributed injection was used. The main characteristics of the two versions are presented in the table: engine volume, L cylinder diameter, piston stroke compression. Ratio power, HP torque, NM 1AZ-FSE 86 869 8 11 0147 155,192 2001 AZ-FE 86 869 5 9 8137 152,190 194 Principle of operation. The peculiarity of the FCE version is the ability to operate on ultra-poor fuel-air mixture in the proportion of up to 30-40:1. While the optimal stoichiometric composition is 14.7:1, the limit for a conventional injector motor, with distributed injection, is 20-24. This is achieved by the fact that the fuel after injection is distributed unevenly over the volume. Due to special reflective notches in the bottom of the piston, a reverse vortex is formed, which reaches the highest concentration near the spark plug, close to stoichiometric. In other areas, the mixture remains depleted. The working process is carried out using some innovations: layer-by-layer mixture formation, 3-mode operation of the injectors, variable valve timing, VVT system, and exhaust gas reignition. According to the changing load and driving speed, the ECU switches on the required mixture formation mode. The injection torque, the number of injections, the configuration of the fuel plume and the position of the regulating flaps in the intake tract are changed. Brief description of D4 engine operation modes: layer or staged combustion, low loads, constant speed. Gasoline is injected at the end of the compression stroke in a narrow plume, reflected from the piston recess, atomized and enters the spark plug area. Here the sufficiently enriched charge is ignited, after which it ignites the remaining depleted mixture, equals 17:40. Homogeneous mixture is used during unstable engine operation modes: starting, warming up, loading, regeneration during braking. Gasoline is injected at the intake stroke, after the piston. The plume is cone-shaped, there is no reflection from the piston, and the entire mixture has a composition approaching stoichiometric, equals 12:15. Two-stage mixing. In the process of transition from layer-by-layer to homogeneous mode, gasoline is injected twice, at intake and compression. The mixture begins to enrich, equals 15:25. Differences from the 3S series: the new engine has an aluminum cylinder block, BC, with an open cooling jacket, the open deck design, in which the cylinders are washed with coolant from all sides. In addition, the through channels make it possible to eliminate the use of sand cores in the casting process and convert the process to injection molding. The structural scheme of the engine is made with deactivation. The crankshaft is displaced relative to the longitudinal section of the BC by 1 cm. The purpose is to reduce the lateral reaction of the piston friction force against the cylinder walls. The point is that thin walls do not allow to bore the BC for repair dimensions. That is, the block is actually disposable. The use of timing chain instead of toothed belt also distinguishes the novelty from the previous line. The rest of the solutions have been transferred from the previous motor with some changes. The solution of the intake manifold and additional flaps has been simplified. The latter are driven by a simple vacuum servo drive and an electromagnetic valve. The passage channels are enlarged and are less soot-covered. The electronic throttle has been changed. It is smaller, the sensors are hidden inside and do not need to be adjusted. 2.0 The fuel rail with one passage hole has a simpler device. The high-pressure fuel pump, HPF, has been improved. In the pressure regulator there is only one non-disassembling valve. The packing is equipped with a spring. And although the leakage of the new pump has become much less, the service life has been extended insignificantly. Problems of Jedi. Unfortunately, the FSE version of the 1AZ generation, despite all the improvements, never became truly mass-produced, and was replaced by the 2AZ generation. The following are the main problems encountered when operating D4 engines. Low life of the fuel injector. Although this device has long been successfully used on diesel internal combustion engines, it turned out that gasoline, as a working environment, aggressively affects its components. 2.0 The fuel rail with one passage hole has a simpler device. As a result, the fuel gets into the lubricating oil and liquefies it. With significant wear, the volume of oil in the crankcase can double in a day or two. And liquefied oil leads to wear of cams, liners, and other parts. Another weak point of the 1AZ-FSE is the exhaust gas recycling system. Despite design improvements over its predecessor, the 3S, the intake manifold, regulating flaps and EGR throttle are covered with soot, resulting in unstable idle speeds, stalling, and jerking while driving. Adjustment of 1AZ timing valves is possible only by selecting the adjustment cups, which is very difficult and expensive, so it is usually not made. But the FE engine of the 1AZ family was a bit more successful, because it lacked the main culprit of most of the woes, the fuel injector. Operating tips service of mechanisms can be significantly prolonged if unfavorable operating conditions are avoided. The most important thing that is contraindicated for D4 engines is low-quality gasoline. Even a small excess of sulfur in the fuel will cause the precision mating surfaces to wear as if from abrasive powder. In order to prevent emergency gasoline leaks from the fuel injector into the oil sump, you should make it a rule to regularly check the oil level with a dipstick. If the latter starts to rise, there is a reason to give the pump for diagnostics. It is necessary to periodically clean soot from the intake system, throttle valves, and EGR, and after 2,000 kilometers run the engine for a couple of minutes at high speeds to burn out the soot on the parts of the casing. When replacing the chain, it is necessary to pay attention that not only the sprocket marks coincide with the marks on the gear covers, but also the timing marks on the chain, made in the form of marked links, with the marks on the sprockets. In conclusion, the 1AZ-FSE engine represents a significant milestone in Toyota's engineering journey, showcasing the potential of direct injection technology. However, its shortcomings have raised concerns among enthusiasts and everyday drivers alike. While it aimed for high efficiency and performance, the reality has revealed a series of challenges that cannot be overlooked. By understanding these issues and implementing careful operational practices, owners can mitigate some of the risks associated with this engine. Ultimately, the 1AZ-FSE serves as a reminder of the delicate balance between innovation and reliability in automotive design. Thank you for watching, and we hope this analysis has provided valuable insights into this intriguing power unit.